Every app you use, Instagram, Spotify, your bank, runs on a database. But what actually happens when you hit search, or post a photo, or check your balance? In this video, we go deep on how databases really work. Tables, indexes, B-trees, ACID transactions, joins, query planners, and when to use NoSQL instead. This is the complete guide. A relational database stores everything in tables, rows and columns, like a spreadsheet, but with superpowers. Each table has a schema, a strict definition of what columns exist and what type of data goes in them. A user's table might have an ID column, an integer, a name, a string, an email, and a created at timestamp. Every row is one record. Every column is one attribute. The primary key uniquely identifies each row, usually an auto-incrementing integer or a UUID. No two rows can share the same primary key. This is the foundation. Simple, structured, and incredibly powerful. Here's the problem. Say your user's table has 10 million rows. You run. Select star from users where email equals john@example.com. Without an index, the database reads every single row, a full table scan, 10 million comparisons. With an index, it finds the row in about 23 steps. How? A database index is a B-tree, a balanced tree structure where every node holds a sorted range of values. Looking for an email? Start at the root. Is your value less or greater? Go left or right. 23 steps later, found. Indexes trade write speed and storage for dramatically faster reads. Most production databases index every column you search or sort by. When you transfer money between accounts, two things must happen. Your account is debited, and the other account is credited. If the system crashes between those two steps, you cannot have money disappear. This is where ACID comes in. Atomicity means all operations in a transaction succeed together or none of them do. Consistency means the database is always in a valid state, no broken constraints. Isolation means concurrent transactions cannot see each other's partial work. Durability means once a transaction commits, it survives even a crash. ACID is a contract, a promise. It is why databases are trusted with the world's money. Real data lives across multiple tables. Orders reference users. Line items reference orders. Products reference categories. A join combines rows from two tables based on a matching column. The most common is inner join. Returns only rows where a match exists in both tables. Left join returns all rows from the left table, with nulls where no match exists on the right. Right join is the mirror. Full outer join returns everything from both sides. The query optimizer chooses the join algorithm, hash join, merge join, or nested loop, based on table sizes and available indexes. Joins are how relational databases earn their name. When you send a SQL query, the database does not just run it. First, the query parser turns it into an abstract syntax tree. Then the query planner generates multiple possible execution plans. It estimates the cost of each plan, using statistics about table sizes, index selectivity, and data distribution. It picks the cheapest plan. You can see this with explain analyze in PostgreSQL. Running a slow query? Explain tells you exactly where the time is going. A sequential scan instead of an index scan, a missing join condition, a Cartesian product. The query planner is one of the most sophisticated pieces of software in any database engine. Relational databases are not always the right tool. When your data has no fixed schema or changes shape constantly, a document store like MongoDB lets you store JSON documents directly. When you need sub-millisecond key lookups at massive scale, a key-value store like Redis keeps everything in memory. When your data is highly connected, social graphs, recommendation engines, a graph database like Neo4j traverses relationships in constant time. Columnar databases like Cassandra and BigQuery are built for analytics, scanning billions of rows across a handful of columns. SQL is still the default for most applications, but knowing when to reach for something else is what separates good engineers from great ones. Databases are the foundation of every application. Tables give structure. Indexes give speed. ACID gives safety. Joins give relationships. The query planner makes it all efficient. And NoSQL gives you options when relational is not the right fit. If this video helped you understand what is actually happening under the hood, subscribe and hit the bell. We publish deep dives like this every week. See you in the next one.